This example is asking us to use 6 subintervals and trapezoids. You'll notice most of these problems want you to do it with rectangles. This one is going to want us to use trapezoids to estimate the area between the curve and the x-axis for this specific equation, and then on this x-interval here from 1 to 3. And so as we do this, the process is going to seem very similar to what you would normally do on a Riemann sum problem. So to start off, we're going to start the exact same way we would start any other left hand, right hand, any other Riemann sum problem. We start off by drawing out our interval, a number line. So starting at 1 on our left endpoint and ending at 3 on the right endpoint. And what I want to do is I want to split that interval up into my 6 subintervals. So I find a delta x now that's going to tell me how far I need to move over before I put another tick mark. So our delta x formula comes from max minus min divided by the number of intervals. So the delta x on this problem, the max of our interval would be 3, the min of our interval is 1, and then they wanted 6 subintervals, so our n is 6. So that's going to get us 2 over 6 or 1/3. That is our delta x. That's how often we need to put a tick mark on our number line. So we come back and label those. Starting at 1 on the left, moving to the right 1/3 would get me to 4/3. Moving to the right 1/3 from there would get me to 5/3. Moving to the right 1/3 from there would get me 6/3, which is also known as 2. Moving to the right from there would get me to 7/3. And moving to the right from there would get me 8/3. Moving to the right 1/3 more would get me to 9/3, which is also known as 3. So I've got my number line broken apart, and then I come through and I write these areas in here. So A1, A2, A3, A4, A5, and then A6. That does a couple of things for me. It makes sure that I did everything right because that last interval should match up with how many ever intervals I'm looking to find. And then it also shows me how I'm going to break this into smaller bite-sized little math problems. So now what I know is I'm going to need to come up with a formula for A1, A2, A3, A4, A5, and then A6. So we have to come up with area formula for all of those. This problem doesn't want us to use rectangles. Remember, this problem wants us to use trapezoids. And so to do that, we need our area of a trapezoid formula. The area of a trapezoid is 1/2 base 1 plus base 2 times the height. So on a standard trapezoid, which looks like this, in that situation, we've got base 1, we've got base 2, and then the gap between those two right there, that is our height. However, as we apply that to our situation, we don't use the trapezoid looking like that. What you're going to do is you're going to rotate that trapezoid up onto its side. And so what you're going to find here is now base 1 is up and down here, base 2 is up and down here, and then our height is actually going to be the gap at the very bottom here. And so that's kind of the weirdness, is we're not really using the standard way, the standard orientation of a trapezoid. We've rotated that trapezoid up and to the right. So now we come back and we got to set up that area formula for each one of our gaps. So we need to have 1/2 and then base 1 plus base 2 times our height. This is again what I just referred to as the assembly line process. So everybody's going to get a 1/2 right now. So 1/2, 1/2, 1/2, 1/2. That's taking care of that portion of it. And now what we need to do is we need to come through and we need to find our base 1 and our base 2 for each of these different areas here. The bases, because these things are going up and down in this situation, these are actually going to be the y values from the two endpoints of our interval. And so we're going to have f of, I'll make that a little bit larger. Don't want to squeeze that in. The f of something's, f of will give us base 1, and then f of the other endpoint is going to give us base 2. And so as we come through here, Again, it's this assembly line process. The more of these you do, the quicker you'll get at putting this together. You can kind of maybe skip a few of these processes, but as you're learning it, this is kind of helpful to let you know where everything is coming from. So now to find those y values, we need evaluation points for each of these. So base 1, which is on the left side here, base 1 of my interval on A1, starting at the beginning here, would be on this left-hand side. So base 1 is 1, and then the right side over here would be base 2. So that'll be 4/3. And then you work your way down the list. So going to A2, the left side of A2 is 4/3. The right side of A2 is 5/3. So that's how we get our base 1 and our base 2. Working our way down. A3, left side, 5/3, right side 2. Working our way down to A4, left side is 2, right side is 7/3. You'll notice that these things connect, right? The left side and the right side. So ideally you're not doing, once you do a calculation for one of them, you'll get the calculation for the next one. So then 7/3 and 8/3. And then on our very last A6 here, there's our left side, there's our right side. So then this would be 8/3 and then plugging in 3. So that's just our base 1 and our base 2. Now we need to multiply all of that by the height. Well, remember the height is the bottom here. That is our delta x in this situation. So our height on all of these is always going to be our delta x. So delta x, delta x, delta x, delta x, delta x. From there, we now get the fun part of this, which is putting all of these numbers probably into your calculator and getting out some real values for them. So we start off with our 1/2, 1/2, 1/2, 1/2, 1/2, 1/2 on all of them. And now we're going to come through and we're going to get those actual function values. So you were going to take 1 and you were going to plug that x value into your original equation to get that side of it, to get our base 1. So when we plug 1 into our equation, we get out 1. Plugging 4/3 into that equation, we get out 52/27. And then that's going to end our base 1, base 2 there. And then we're going to come through and we're just going to, I kind of try to do these things all at once so that my mind is staying in that process. And the other thing here is notice that we go down and we're wanting f of 4/3. Well, that was what we just got out. So we always get out half of it now for free. So 52/27. Now we got to plug in 5/3 into that equation, and that's going to get us 59/27. Then we get that piece for free on the next one. And then we plug in 2. When we plug in 2, we get out 2. Then that gives us 2 right here. Then we got to plug in 7/3. Plugging in 7/3 is going to get us 43/27. And then that gets us half of the next one. And then plugging in 8/3 into that equation gets us 32/27. And that's going to get us half of the next one, so 32/27. And then plugging in 3 gets us 1. Don't forget that all of these are being multiplied by that delta x. So times 1/3, times 1/3, times 1/3, times 1/3, times 1/3, times 1/3. And then the final part of this is to go ahead and throw all of those values into your calculator to get out the actual area for each one of those regions. So when I multiply this all out, I'm going to get 79/162. I multiply this all out, I get 37/54. Multiplying this all out, I get 113/162. Multiplying this stuff all out, I get 97/162. Multiplying the second to the last one, I get 25/54. And then doing it one last time for this last section, I would get 59/162. So that is the area of the trapezoids for each of those 6 regions. And so now to get our final answer, our approximation for what that total area is, we just take up all of those singular rectangles, or not rectangles, all of those singular trapezoids, and we just add them. Add up all of those little answers and we'll get the total answer. So then we add all of that stuff up, and out of there we end up with 89 over 27. That would be our final answer for the estimation of the area between the curve and the x-axis using trapezoids to do it. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.